So what we're going to do today is we're going to talk about different characteristics of quadratic functions, and we're also going to graph them. And we use the calculator for sure, so definitely make sure you have your graphing calculator with you. So a quadratic function is a function that's in the standard form of y equals ax squared plus bx plus c. Okay, and that looks familiar because that's what we've been factoring for a long time now. The function's graph is a smooth and symmetric U shape, and it's called a parabola. And the vertex is the turning point of that parabola. Okay, so then what we're going to have you do is we're going to have you graph each of these quadratic functions, each of these parabolas, using a table of values. And you can use your calculator, or you can just know how to do it. In other words, if I wanted you to take -2 and square it, I'd get a 4. If I wanted to take -1, remember y equals x squared. These are my x values. If I take -1 and square it, I get +1. 0 squared is 0. 1 squared is 1. 2 squared is 4. If I'm going to graph these ordered pairs, I'd go -2, comma 4, plot a point, -1, 1, plot a point, 0, 0, plot a point, 1, 1, plot a point, and 2, 4, plot a point. This is my smooth U-shaped graph whose turning point is the vertex. This is our turning point. This would be my vertex, and my vertex happens to be 0, 0. What's interesting about looking at the table of values is if I were to circle that vertex, the y values on the other side of that vertex are the same. In other words, I'm symmetrical on either side of my vertex. Let me see if I can find my, oh, here it is. So if I look on either side of the vertex, I've got a y value 1 and a y value of 1. And then if I move this, I guess, I've got on either side of that, I've got equal values. Okay, so that's kind of a symmetrical look at your parabola. If I wanted to do this on the graphing calculator, I'm just going to go into my y. Let's try that again because now I'm, okay, hold on. Let me go back here. Let me go back here. Let's see if this works. Let me see. Okay, so if I go to y equals, perfect, and then I type in my x squared, and I graph it, there's that parabola, same exact U-shaped graph. If I go to my table of values and I want to try to find my vertex, I know the vertex is right here at 0, 0, but I want to find a pattern in the x and the y coordinates. If I start moving up, I'm going to start seeing a pattern, and the plan is that in order to graph any of these parabolas, if I can find a pattern in which my center point is my turning point, because on either side of that center point, the values are the same, that's a perfect way to graph your parabola. Okay, so what happens now when I look at this next one? The next one says to you, okay, well now let's do y equals negative of x squared. Well, I'm going to go right to my graphing calculator, or I could do it by hand. I'm going to go to y equals, and I'm going to actually change this, and I'm going to go to the negative symbol, x squared. And look what happens when I graph it. That u turned upside down. And if I go to my table of values and I try to line up the ordered pairs so that I've got a pattern, a symmetrical pattern on either side of the turning point or the vertex, here it is. -1, -1, +1, -1, -2, -4, +2, -4. That's what I'm going to be filling out on my note sheet. So -2 is -4. -1 is -1, 0 is 0, 1 is -1, and 2 is -4. Remember, order of operations, when I'm trying to plug this in, if y equals the negative of x squared, and I know that x is -2, order of operations says I better do what's in the parentheses first. -2 squared is just 4, and then I bring down the negative. So if you're wondering why it came out to be negative, that's the reason. So now I've got -2, -4, which would be here, -1, -1, 0, 0, 1, -1, 2, -4, and now there's my parabola. Notice how one opens up and one opens down. Why do you think that happens? Okay, and hopefully you said, well, the negative must be what's making it open down. So a parabola opens upward when x squared is positive. Okay, if this is the case, the vertex of the parabola is called a minimum value, right? Because if I take a look here, this is the lowest point on my graph, that vertex. Okay, so then the parabola opens downward when x squared is negative. If that's the case, then this is the highest point of the graph. We'd call the highest point, or the vertex, a maximum. Okay, so then there's something that's called the axis of symmetry. And the axis of symmetry is a vertical line that divides the parabola into two symmetrical halves. It's a vertical line. The equation of this line, and we've talked about lazy lines and excited lines, and vertical lines are excited lines, is always going to be in the form of x equals something. Okay, it's going to be x equals, axis of symmetry is an equation, it's a line, x equals something. So if we wanted to identify the axis of symmetry, which is part C, the first thing I think we need to do is be able to identify the vertex. The vertex, the turning point, is right up here at 1, 5. So the vertex is 1, 5. That vertex is the highest point. That vertex is a maximum. Identify the axis of symmetry. Well, that's the equation of the vertical line that goes right down through that vertex. So this is the axis of symmetry line. Here it is. Well, what's the equation? The equation is what's the x coordinate it goes through. The x coordinate is 1. So the axis of symmetry is the equation of x equals 1. The axis of symmetry, by the way, is all about what the x is, okay? So let's take a look at this next one. Number 2, what is the vertex? The vertex is down here at 1, it looks like it's going to be at, let me get this right, -2, -5. There's your vertex. This is the lowest possible point. The vertex is a minimum. And the equation for the axis of symmetry, the equation for this particular vertical line right here would be, I'm going to put AOS, axis of symmetry, is x equals -2. It's all about what the x is, okay? And the x's mean the coordinate of the x, of the vertex, x coordinate of the vertex. Other things that you need to know. The zero of a function. Okay, zeros. In this case, the 0 happens to be an x value that makes the function equal to 0. The 0 of the function is also known as the x-intercept. We know stuff about y-intercepts, and y-intercepts are where graphs cross the y-axis. X-intercepts are where graphs cross the x-axis. Just that easy. You might have, in terms of a quadratic equation, you could possibly have 2 zeros. You could have 1 0, or you could have no zeros. Take a look at these next 3 examples. Does that first example cross the x-axis? And it does. It crosses the x-axis in 2 places. It crosses the x-axis at that point and at that point. So the zeros are what the x's are. It almost looks like it'd be the equation for the axis of symmetry. It's not. It's under the heading of zeros. But this one on the far left, that 0, whoopsie, didn't really want to do it in highlighter. I guess I could. This one would be x equals -1, right? Because that's the x value. This 0 right here where we cross the x-axis, this one right here would be x equals 2. So those are your zeros of this particular parabola. What are the zeros in B? What's the x-intercept? Where does the parabola cross the x-axis? Well, it doesn't. There are no zeros here. Okay? How about quadratic C? Where does the parabola cross the x-axis? Well, it crosses the x-axis right here. That value is x equals 1. There's only 1 0. Okay? So you could have 2 zeros, which is going to be this one right here. You could have no zeros, or you could have 1 0. Domain and range, talked about this already. The domain is always going to be the set of all x values. The range is always going to be the set of all y values. Okay? In parabolas, the domain is always the same no matter what. every answer for the domain of a parabola always, always, always is all real numbers. So domain, no matter what, any parabola is the set of all x such that x equals the reals. Always, okay? Always, 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 always. The range all depends on the vertex, okay? It depends if it's a max or a min, because if you've got a minimum value, then your range is going to be that particular smallest y value or anything more than it. If it's a max, it's going to be that particular y value of the vertex and anything less than it. So it's all about the vertex. So if you have a min, okay, your range is going to be set of all y's such that y is less than or equal to whatever the y value is of the vertex. I'm sorry, greater than. Fix that, fix that. If it's the lowest point, it's going to be all the values that are greater than or equal to. Sorry. If your vertex is a max, if it's the highest point, then your range is going to be the set of all y such that y here is where you do less than or equal to the y coordinate of your vertex. Okay? Let's take a look at this first graph. Domain, there should be no issue on the domain. Domain's the same no matter what. So on this particular first graph, I know that my domain, and this is how you write it, the set of all x such that x equals the reals. At this point, I might as well go and do it over here too, right? Because this domain has to be the exact same thing. So graph number 2, set of all x such that x is equal to the reals. It's the ranges that change. Well, take a look at this vertex. This vertex goes through this -4 on the y-axis, and any point that's above it works. So my range becomes y such that y is greater than or equal to -4. Okay, take a look at graph number 2. Right now, my vertex happens to be the max, and it goes through this point, which is 3. So my range is the set of all y's such that y is less than or equal to 3. Okay, that's all you have to do for domain and range. That's it. Should not be hard. Last but not least, use your graphing calculator to graph these quadratic functions, find the vertex, find the axis of symmetry. You don't have to sketch these things. All you have to be able to do is type in your calculator, locate a pattern, and go. So let's erase this. Go to y equals, get rid of what's in there. Oh, I should actually do that. Hold on. Zuma. Oh boy, come on. Perfect. Okay, so this next graph was y equals, or the next quadratic, 3x squared minus 6x plus 4. Let's take a look at this graph. There it is. It's a min, okay? We've got to find the vertex. The vertex is, for sure, right here. It looks like, I'm not positive, it looks like it's 1, 1. Don't know. I'm going to confirm it with the table of values. So table of values. And what I'm going to try to do is find a pattern in the y's. And if I actually go down a little bit, I should be able to see this pattern. I actually happen to see it, but I want to put it on the calculator a bit better. One more. Nope. Yes. So right now I've got a pattern in the y's, right? 28 to 28, 13 to 13, 4 to 4. Hey, we were right. That's our vertex. And that means that the axis of symmetry happens to go right down through that x coordinate of the vertex. This is easy. All I have to do is come over here and say, you know what, my vertex is 1, 1, and my axis of symmetry is the equation for what the x is, and the x is 1. Bingo, done, finished. Let's take a look at the next one. Let me erase all this other stuff. Erase, 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 erase. Go back to y equals, brand new equation. This one is -x squared. Hey, it's a -x squared. Hopefully you realize this thing is going to open down. It's going to have a maximum. -x squared plus 4x. Let's take a look. Does it really, in fact, open down? Sure does. Vertex looks at like negative or positive 2, 3, maybe, something along those lines. So let's see on the table of values. Let's see. Nope, I was not right for the vertex. It's positive 2, 4. Not a big deal. I'm always going to confirm it with the calculator. Again, find a pattern in the y's. Here's my pattern in which my turnaround point is right here. So that's my vertex, and the axis of symmetry is what goes right through that x coordinate. So all I have to do is come over here and say vertex is 2, 4, and the axis of symmetry is the equation. Can't stress that enough. X equals 2. All right, you are done. Homework should be easy.